Differential calculus. The fundamental theorems in differential calculus are Rolle's theorem, Lagrange's mean value theorem, Cauchy's mean value theorem, and Taylor's theorem. Okay, now let us see in detail the case of Taylor's theorem. Let us see what it says. So, Taylor's theorem states that suppose a function satisfies the following condition. Taylor's theorem. The function should satisfy the following condition that f of x and f of n minus 1, the derivative of x, are continuous in the closed interval a comma b, and f of n minus 1 x is differentiable in the open interval a comma b. Then in such a case, there would exist one point C in the open interval AB. So in such case, there would exist one point C. Such case, there would exist one point C would exist in open interval A comma B, such that f of B equals f of A plus B minus A, f first derivative of A plus b minus a the whole square by 2 factorial f second derivative of a, and this goes on and on and on up to that particular n minus 1 n minus 1 derivative. We write it down like this: n minus 1 factorial f n minus 1 power plus b power minus a power n by n factorial. Then f nth derivative of here c. So this particular c is what we are going to find out when we find out by solving this particular problem. We'll be able to find out what this value of c is, and this value will definitely be present in the open interval between a and b. So to understand the Taylor's theorem even better, let's try solving a particular problem and analyze how this Taylor theorem works. So let us consider a problem wherein they have told us to verify the Taylor's theorem. They have asked us to verify Taylor's theorem with n equals 2 for the function f of x equals x into x minus 1 into x minus 2. In the interval range, they have given the interval range as the closed interval between 0 and 1 half. So we have to do the verification of the Taylor's theorem with n equals 2 for f of x equals x into x minus 1 into x minus 2 for the closed interval which is between 0 and half. So let us try to expand this particular equation so that we'll get to know what exactly it is. So how do we expand? So x into x minus 1. So it is x square minus x brackets and x minus 2. So expanding even further, we get x cube minus x square minus 2x square plus 2x. So let's simplify it further. So we get x cube minus 3x square plus 2x. So we get f of x equals x cube minus 3x square plus 2x. So what is the first condition of the Taylor's theorem? Taylor's theorem first says that f of x and f dash of x, that is n minus 1 of x. So here we have n equals 2, so n minus 1 equals 1. So let us try doing this f dash of x, so which is actually f of f power of n minus 1x. So on differentiating this particular equation, we get x cube will become the differential of x power n is n into x power n minus 1. The differentiation of x power n equals n x power n minus 1. So the differentiation of x cube is 3x square minus 3 into 2 6x plus 2. Okay, just let us observe whether these two are continuous in the open interval. Are these continuous in the open interval between 0 and 1 by 2? So to find out whether it is continuous, we have to just substitute the values of the extreme parameters like 0 in this particular equation, and we find out that there exists a real number, and we can conclude saying that this particular function is continuous. Okay, shall we substitute it? And when we see, we get the value as, okay, 0 here we get, and the second equation we get 2, and we can say that this particular equation is continuous. So this is continuous, and the first condition of the Taylor's theorem is satisfied. Now let us go on to find out whether f power n minus 1 x is differentiable in a and b, in the closed interval a and b. So as we had got in the previous slide, that f n minus 1 is f dash of x, 3x square minus 6x plus 2. So let us now substitute the values of the range. So f of 0, if you are putting, we are getting 2. F of 1 by 2, we are getting the values as, we are getting a particular value. Like, let's calculate the values. 3 into 1 by 2, the whole square, is 3 by 4, 3 by 4 minus minus 6 into 1 by 2 plus 2. So we get the answer as minus 1 by 4. So this particular value is also existing. So the conditions of the requirements of a Taylor's theorem is satisfied, and now we can use the particular equation. The equation states that f of b equals f of a plus f of b minus a. I'm sorry. So b minus a f dash of a plus b minus a whole square by 2 factorial f double dash of c. So let us substitute the values of this particular equation and find out whether what is the value of c. Find out what is the value of c. Okay. So we have f of x equals, these are the main equations. So these are, sorry, this is our main equation. So let us write down. So what we get, our range is between 0 comma half. So what it is asking, f of half equals f of 0 plus half minus 0 is half, f dash of a, as we have found in the previous slide, we can say that f dash of a, the value to be as, let us write down the value of f dash of a as 2, that is f dash of 0 is 2 plus b minus a the whole square, the value will come to be 1 by 4 by 2, and again f double dash of c. So f double dash of c means that in f double dash of x, we have to replace x with c, and we get the equation to be as 6c minus 6. So let me erase this part so it should not be confusing for us in the further steps. So when we are going to expand this particular equation by substituting the respective values, we get that. So f of half is equal to 3 by 8, then f of 0 is 1, and this f of 0 is 0, and this we get 1 plus 1 by 8, and if I take 6 common, c minus 1 I get. I just can cancel things out, and if I have to rearrange the equation, it becomes like 3 by 8 minus 1, and 6 by 8 minus, it becomes 6 by 8 to c minus 1. So solving for this, minus 5 by 8 equals 6 by 8 into c minus 1. 8 cancels out, that is minus 5 by 6 equals c minus 1, and c equals 1 minus 5 by 6 equals c equals 1 by 6. So by getting the value as c equals 1 by 6, what we can observe and conclude is that c equals 1 by 6, and this exists between the values 0 and half. And this is the Taylor's theorem, and we have been able to solve a simple problem based on Taylor's theorem to gain an understanding.